and brought. Salutations and welcome. This is the final design review of the MediDrone. This spring 2023 senior design project has been supported by advisors Dr. Ritchie and Dr. Way and brought to life by interdisciplinary engineering undergraduate students V. Andakumar, Mechanical, Lior Barak, Aerospace, Seba Villalobos, Computer, and Electrical Engineering undergraduates, Joey Hodson, Ryan Grant, and Seth Horowitz. We will present the MediDrone, a state-of-the-art development in drone delivery technology for medical utility. Throughout this presentation, enjoy. The concept of MediDrone was derived from lack of current art in medical delivery drones. In times of emergency, complex issues arise which must be addressed in order to save lives. Spoilage of medicines, depletion of ground delivery, unavailability of air delivery, high cost of commercial drones, and lack of technological access to medical delivery drones are factors of emergency triggered mostly by natural disasters, in which MediDrone aims to alleviate.
Here is a short demonstration of how our payload is to be loaded and attached to the drone.
Here we have the design for our precision landing beacon. Right here, the voltage is sourced from a 9-volt battery and is connected over to these resistors as well as the voltage, or the supply voltage for the timer. The current's then collected down from here past the resistors into the first or each column of the array and is collected into the collector of the transistor right here. At the base of the transistor is hooked up to the timer, or the output of the timer, and these currents add together into the emitter, which goes into this array of LEDs. The values of the resistors at the bottom of this timer right here are determined by equations that can be found in the datasheet, where the values determine the frequency and duty cycle for the timer's output, and for the detection of the infrared signal, that it's most optimal to have it at 39 kilohertz and have a duty cycle of 50%. In the case, beacon sits here with the LEDs exposed, the electronics over here covered, and terminals here for the 9-volt battery to connect to. Here we have the design for
the beacon flashes at a known frequency, so the algorithm looks for pixels that are flashing at this same frequency to find positions that could be created by the beacon. The red is all of the pixels that are on, but were also on half a period ago. So this is light that we want to filter out. Now that we've filtered out all the static light, we look at all of the pixels that have a history of flashing at the correct frequency. Using these pixels, the ones that pass the threshold are considered in an average, and this gives us the estimated position of the beacon. To get an estimate of how accurate our algorithm is at the moment, we look at the previous 5 guesses and we consider how far any of them are from the average of those 5. If they're all very close together and they fit in a small circle, that means that our estimate's highly accurate and we can safely choose that position as the beacon target location.
Hey everyone, it's Joey. You can see that the boards are drawing actually very little current. This is our original power distribution board. All 4 boards and the PDB together at the time, with no load from the motors obviously, were only drawing 50 milliamps, which is, you know, honestly not too much, right? So this isn't going to load too much on the drone's battery. It is seen in the video that the boards are picking up all the hand gestures that I'm giving it. So the boards are programmed to detect any object and assert to the flight controller that any object is within 100 centimeters on their respective sides. The video footage was captured shortly before the midterm demonstration. Dr. Ritchie informed us that the noise, or so I thought was noise, was most likely due to crosstalk between the ultrasonic sensors. And that's given, you know, that these boards were facing in the same direction and placed in close proximity to one another. And this theory was pretty much confirmed when the boards were actually attached to the drone on their respective sides. Each were facing 90 degrees away from one another too. So in this video you can see me with a cardboard plate. You can see me slowly stepping away from the drone. These were some tests I ran, and you can see that it detects up to 100 centimeters, and once I get to that 100 centimeter mark, you can see the red LED, the signal, start to jitter a bit. But again, you know, within that 100 centimeters, the signal is pretty consistent. And again, you know, this 100 centimeter threshold could change, but we didn't have enough time to really integrate this with the flight controller due to, you know, trying to get the flight working properly. So there's probably some optimal distance these boards need to detect, but, you know, as of right now, it's still 100 centimeters. Hey everyone, it's Joey. You can see that
Still strong.
Here's our first test with the drone. We were able to get all 4 motors to rotate, but we didn't have full control over the different speeds. Here's our second video where we were actually able to get the drone up in the air. But it was only for a limited time. This is our first real flight video. We were able to get the drone to move, but we didn't have good control over it, so it crashed. Here's where the drone was controlled using the flight controller. So the flight controller has an automatic test where if there is no acceleration applied to the motors, that it will automatically stop. And then we were able to get to again. just to hover across the floor. We wanted to make sure we had good control of the drone. Here's our first test outside with the beacon. We were trying to see if we could get the drone to sense the beacon. So unfortunately our leg broke off there. Here's another video during the same day doing another test. The landing gear had broken, so it might fall off again in this video. Here's our first test in the grass, where we have good controlled flight and we were able to go to a good height as well. Fortunately, we had a low battery, so it wouldn't go any higher at that point. And this is our first flight with full battery. We were able to get the drone to about 10 feet, and then it hovered there for 10-15 seconds, and then we brought it back down.